H323 is the first of the three voice protocols we'll discuss. SIP and MGCP are the other two. And what our goals are for this nugget is to break it down, look at the architecture, how this protocol works, follow a call flow of what typically happens, which is huge for troubleshooting this, trying to find issues. And then we'll look at the configuration of not only an H323 gateway, but a gatekeeper as well. Let me pre-apologize for my stuffiness. I am stuffy if I sound like it. It's the change of seasons here in Arizona. We only have two, summer and winter. And we're in the beginning of November, which is our winter season. It's a freezing 65 degrees outside. And every time that happens, I just get a cold. I should be very grateful because that's about the only sickness I get. So I'm just sniffly. I suppose one of the benefits of IP-based communication, which you're actually experiencing right now, is you can't catch my cold. So this is a protocol breakdown of H323. I actually grabbed this graphic from Wikipedia, which is it's a great looking graphic. And I want to make sure I emphasize what we're focused on. Let me just get the right pen color. This is H323. Now, H323 defines standards for all this other stuff over here. So, I mean, you can interface with all the different audio codecs, which we've come to know and love. But it also does video codecs as well. It supports data application, which is, for instance, like shared whiteboarding. If you remember the old Windows net meeting where you could bring up a whiteboard in the middle of your call, that would be a data application. And there were standards that are available for that. But these, while H323 interfaces with these, this is not a direct component of H323. H323, as we saw on the voice protocol core, is really responsible for setting up the call, making sure that the call remains established, for terminating or tearing down the call, for exchanging features, and all those components put together makes H323 possible. Now, one of the things, it was funny when I was thinking about, okay, well, what do I say about H323? It's the oldest of the three protocols, which initially sounds like a bad thing because in technology, as soon as you say old, it's like, oh, well, nobody uses that anymore. But I would say H323 is the most widely adopted and widely supported. And I encourage you to do this. I just was thinking of, it'd be good to throw some comparisons up. I just typed in Google SIP versus H323, and first link right on there. I thought was an amazing job of breaking this down. This guy actually took the time. Look at this. He actually went through and said, okay, here's the philosophy behind it. Here is the complexity, the reliability. And what you'll get after reading this thing a little ways is, number one, that this guy doesn't like SIP at all. You can see he's got this one highlighted like ding, 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 the clear winner. It's kind of like, well, SIP is a 14-year-old protocol with a vast number of interoperability problems. It's been successfully deployed in some environments, those closed environments where, you just get the feel, which is, I will say, partially true, that SIP just needs to evolve. I mean, it just doesn't have the amount of time and traction that H323 has had. And H323 was designed for this. It was designed for voice conferencing. It was designed to interoperate with the public switch telephone network. So you will get a lot friendlier in terms of interoperability with H323. Now, inside of this protocol, you see three major components. We see H225 call signal. Hey, this is like I should show this to my kids. It's like red and blue make purple. So we've got call signaling. We've got H245, and then we got H225 RAS. Think of these like sub protocols, right? You've got TCP/IP, which really has inside of it like TCP and UDP and IC. I don't have to write them all up because I'll mess them up, but you get the idea. There's all these sub protocols. These are the three core sub protocols of H323. What are they? H225 in its root, they note it here as call signaling, is the one that is responsible for things like call setup, call teardown. So when and we'll see the call flow in just a moment, but when you have let's say a voice gateway that wants to send a call to another, the very first message that it's going to send is an H225 setup message saying, hey, are you ready for this call? I've got a call that is coming to you. Now, over next to it is H245. Think of this guy as your feature exchange. Now, keep in mind, when I am writing this down, Let me finish writing. When I'm writing this down, there are more things that this does, and you know I'm using a broad brush stroke. You know what I mean, right? So this is the main feature of each one of these, but keep in mind that there are these little sub-features underneath. But the main feature of H.225 is feature exchange. What's that mean? Well, feature exchange is, for instance, when I have phone A calling phone B over here, or gateway A calling gateway B, they have to agree on a codec. Well, how are they going to do that? You know, who's going to say I'm using G.711 or I prefer G.729? Well, that's the job of H.245. It's going to exchange and say, oh, well, here are the codecs that we support. Are you good with these? And the other says, oh, yeah, we're good with, or no, we're not. And then the call doesn't happen. Main feature of H.245. Last one is H.225 RAS. If you have a Windows background like I do, every time I see RAS, I think of remote access server, where you would set up a Windows server to, take modem calls or be a VPN server or something like that. Well, H.225 kind of steals that acronym away. Actually, Windows probably stole it from H.225. It really stands for registration, admission, and status. Registration, admission, and status. And there is one key piece I want to add to what would use this protocol, and that is something abbreviated GK, gatekeeper. So as H.223 grows and grows and grows and grows, let me clear this off for a second. As you grow and grow and grow, it becomes very inefficient to start pointing all these gateways to each other. I mean, one of the key points of H.323, and we mentioned this on the protocol core, is that it is a peer-to-peer protocol. And that means that every endpoint has intelligence inside of it. Well, that's great because if essentially the endpoints don't have to rely on anything, and if everything goes down, it can still survive, and that's why remote survivable or survivable remote site telephony (SRST) really relies on a foundation H.323 style of configuration. But the problem with peer-to-peer is it runs into scalability challenges. For example, let's say this gateway, let's say these guys are all connected over an MPLS network, right? By the way, I did a micro nugget on what is MPLS. That was fun. So if you're curious of what is MPLS, Google that and type in Jeremy, what is MPLS, and I bet you'll find it. So inside of here, all these guys are connected over an MPLS network. Let's say we've got all the 1xxx extensions up here, 2xxx extensions over here, 3xxx. You get the point, right? We kind of go all around the globe. Well, if we're using a peer-to-peer configuration, then I'm going to have to go on here and say, okay, to get to 2xxx, go here. To get to 3xxx, go here. To get to 4xxx, you get the point. And then this guy's like, okay, to get to 1x. I mean, these are all manual configurations I'm having to type in. And before long, I mean, 4, 5, 6, 7, 8, 9 sites, you're just like, you explode. You can't handle it anymore because it's too much manual config and pointers going every direction. Thus, enter the scene, theme music included, gatekeeper. What the gatekeeper does is registration, admission, and status. So all of these guys report to the gatekeeper. And I'm putting these looks like WAN links going. They may or may not be directly connected to the gatekeeper at all. Likely they're not. But essentially this becomes your central dial plan. 1xxx, 2xxx, 3xxx, and all that kind of thing. And so when this guy calls 2xxx, instead of having a manual dial plan on there, it says send everything to the gatekeeper. And this guy goes, okay, I don't know how to get to 2xxx. Where's that at? Gatekeeper, who has that manual configuration, uses RAS. And by the way, this was a RAS message. That's why it's purple. We all know RAS is purple. Gatekeeper comes back and says, oh, to get to 2xxx, you need to go to 59.32.69.3. Whatever IP address that gateway is. He goes, okay, great, thanks, and then he contacts him directly. One major function, registration, admission, and status of that protocol. That's one major function of the gatekeeper. Another major function of the gatekeeper is bandwidth control. So you can divide your network up, which is getting pretty messy, so I'm going to use green, into different zones. And I can say, okay, zone 1 only has 500 kilobits per second available for voice. And zone 2 only has 100 kilobits per second. Now, Zone 3, they're awesome. They got 50 megabits per second, whatever. So you define how much bandwidth each one of these zones has. And as each call happens, it goes, okay, let's see, you use the G.711 codec. I have a specific value, we'll just say 128 kilobits per second associated with that. So I'm going to subtract that out. So you've got such and such bandwidth left. So now as calls start coming out of there, now you're really seeing registration, admission, and status. You see I'm trying to stick that in your head. Registration, admission, and status. Admission says, I'm sorry, you can't call Zone 2 right now because Zone 2 does not have the bandwidth available. Because they don't even have enough bandwidth to make one G711 call with that 100 kilobits per second. So that's one of the functions, another one of the functions of the gatekeeper. That's really all this protocol is focused on. So again, we've got call setup, feature exchange, and then registration, admission, and status, which is all gatekeeper. Can I just say, I feel great. I have been sitting at my desk creating these slides, sniffing and sneezing, and I'm just, like I have this pile. It's disgusting. This pile of old Kleenexes because I'm on this efficiency thing. I'm like, you can't just use a Kleenex once, right? You have to really use it. So I've got this pile of Kleenexes there because I'm blowing my nose every 2 seconds. Since the minute I stood up and started talking to you, I have not sneezed, I have not coughed, I have not blown my nose one time. This is great. Let's talk about H323 components. So these are the pieces that make H323 tick. And you can go, also keep in mind H323 industry standard protocol. You can go to the RFC standard and you'll find explicit definitions for how these things have to work because they're all standards based. So I could have a Cisco H323 gateway that talks to vendor X, and that's no problem at all. It's all the same standard. So components. Number one is I'm going to come down here because this gets mixed up a lot. H323 terminal. An H323 terminal is an endpoint that speaks H323 directly. Very few of these out there anymore. I will say Microsoft Net Meeting, if you can go back. Matter of fact, I think many people haven't even heard of this thing. Just going to bust out this, just typed in Microsoft Net Meeting, and it's funny. It's like, download it now, April 2004. Look, it's included in Windows 2000. And that's like, what happened to Net Meeting? It's gone. And then there's like, great, Wikipedia. So we've got a little Wikipedia. Oh, there it is. Oh, man, this is like, it's like when you pull open the old Atari pictures and you're like, I used to have an Atari. Like I remember this picture so well. So this was the old Net Meeting that came with Windows 2000 apparently, where you could make calls. Now, if your computer was running Net Meeting, it was an H.3. There you go, right there, H323 terminal. It was considered a terminal which could interface directly, and you could actually have terminals, since it's peer-to-peer, terminals calling each other directly. They don't need this H323 gateway. It's a fully functional protocol on its own. However, H323 is a real heavy protocol. It eats up a lot, and it's just difficult for the devices to run it and support it. So that's why H323 terminals would usually only exist on a PC. Like you wouldn't see many phones out there that natively support H323, although they may exist. So these guys could call each other directly, but unless you have a bunch of Windows 95 Net Meeting terminals out there, chances are you won't see too many of these. You will mostly see the H323 gateways. Now the gateways is where the voice gateway, the Cisco router itself, speaks the H323 protocol and allows you to attach devices, which it uses those DSPs to start transcoding the audio into a codec and all that kind of thing, and then uses this to communicate with other gateways. So this guy is not, I'll put a line through it, he is not an H323 terminal. He is an endpoint that happens to be connected to an H323 gateway that's doing all the work for him. So that's where H323 fits in. So we've got the terminals, very rare, gateways, very common, and then we've got the gatekeeper. Gatekeeper is we already talked about him. He uses that RAS protocol, does the finds out where your endpoints are located, kind of a central directory, if you will, like a white pages, as well as bandwidth control and allow or deny certain hosts for calling each other. I mean, there's a lot to a gatekeeper. We'll actually talk more about him in a second. MCU, last industry combined or defined component, is a multi-point control unit. This one is used to do like conference calling. To where a bunch of signals come together. And it could be audio conference calling. It could be video conference calling. But essentially, all the signals come into this device, which can mix all those signals up and send them back out as a unified stream. I mean, a lot of times we take conference calling for granted, but there's a lot of work that goes into it. You really are taking, if this guy jumps on and this guy jumps on and this guy jumps on, you're taking all these incoming streams and mixing them all together and sending them out as one stream. That's beyond what most gateways or what an endpoint can typically do on its own, just in sheer processing power. So they have a separate device defined for it. Now let's look at how these calls get set up. Look at kind of the flow behind the scenes. And this is really valuable for troubleshooting, and when you've got that debug and you're going, what does that mean? Really helps out. Two different scenarios. We've got direct between two different voice gateways, very common. And then we've got with gatekeeper, which once you've grown large enough, you've got that central point of contact that manages your dial plan and your bandwidth and all of that. We'll look at both of them. So first off, direct. Let's say this phone, which we'll peg as 1001, picks up and calls 2001. On the right hand side. We're assuming dial peers are all accurate and pointing to the right IP addresses, but dial peers by default, unless you specify, will use H323. So the first thing that's going to happen is he's going to send an H.225 setup message. Now this is the root H225, the session management. This is not the RAS component. The only time H225 RAS comes in that you saw on that last slide is when the gatekeeper gets involved. So this is just straight setup message saying, hey, I've got a call for you. Now this gateway, I'm thinking gatekeeper, gateway receives that and sends back an H225 proceeding message. Think of that like an act. Like, oh, okay, I got it. Looks good. I'm gonna start doing something with this call because it's gonna be quickly followed up with an H225 alerting. What do you think's happening there? Ring. This guy is getting that ring sound on his phone. This guy on the other end is hearing that. That comfort that something's happening. It's not just dead air. That's the responsibility of that H225 alerting. That's how the other side knows to start playing that little noise on that the call is proceeding. So this guy's like, oh, there's a call for me. Picks up the handset. This guy is now going to send an H225 connect. Like, hey, we're good. We have some action here. And at this point is where that H245 steps onto the scene to negotiate the features. It's going to do a little exchange saying, okay, what codec? Let's figure out how RTP is going to look. And then we have our stream. And this is, once you've decided on a codec, you got the RTP and RTCP, real-time transport protocol and control protocol that are making all of that happen. One's giving you the audio, RTP, one's delivering statistics, that's RTCP, and your conversation occurs. Now I'm kind of orbiting around this point because this is a big point of failure. What if this guy says we must use G.711? And this guy says, no, my friend, we must use G729 because we've got a low bandwidth connection. At that point, here's the symptom. This is how you know something like that's happening. Phone, ring, ring, ring. You hear brr, brr. As soon as the handset is lifted, like both sides are connected, this message happens. You hear So okay, that gives you an immediate step in troubleshooting. Call is happening. You get the trouble ticket. Hey, I'm calling the other side. I'm hearing it ring. They hear their phone ring, but then we get a fast business signal. What is it? Almost 99% of the time, it's going to be a codec mismatch. Because that codec negotiation doesn't happen until as soon, it's like a just-in-time sort of negotiation. As soon as that connect message occurs, H245 negotiates the codec, and if there's no common ground, the call disconnects. Now, Life goes on. How you doing? Great. I'm watching CBT Nuggets right now. I'm getting certified on ITIL, looking at Michael Shannon's series. It's amazing. Okay, I'll let you get back to it. Click. The call gets hung up. Actually, I just found out Michael Shannon did an ITIL series, which I always thought ITIL made your eyes bleed until I started running my own IT organization. I'm like, man, I see a total need for that. So I'm starting to check that out right now too, and it does kind of make your eyes bleed, but it's still really good stuff because ITIL is all about standards and planning and standards and planning. So where were we? Okay, we talked about that. We're ready to get back to our ITIL series. We hang up the phone, and so now we send an end message. Now that is actually done using H245. 245, remember, is responsible for the features, so it's like, okay, whoa, it looks like we have a session end happening, but the one that's really going to close the connection is H225. We've got H225 that comes in and sends a release. Because H245 is, think of him as like the mid-call stuff, the squishy gooey, I'm pushing a hold button, midstream audio needs to stop, all that kind of stuff. That's all H245. But once the call is done and we're ready to tear it down, H225 steps back onto the scene. It's really its whole focus is setting up the calls and releasing the calls. All right, well, let me clear this off and talk about the gatekeeper world. So let's say same scenario. We've got extension 1001 and 1002 that now you're now employing a gatekeeper. How does the call flow change? Well, first off, let me talk about beforehand, but behind the scenes. These gateways can actually register their endpoints. These are POTS endpoints. They can go to the gatekeeper and say, hey, I've got 1001. The gatekeeper is like, oh, okay, great. So it kind of builds a dynamic database of where these different endpoints exist. There's a lot of manual config with the gatekeeper, but some of it can be dynamic as well. So all of that is assumed registered at this point. He picks up and calls 2001. His dial peer, instead of pointing to him, because remember, that's the whole point of a gatekeeper is to trim down all those manual dial peers. His dial peer just says, hey, send everything to the gatekeeper. He'll tell you where it is. He will send using, again, now we're on that H.225 RAS, registration, admission, and status, because we're going to remember that. He's going to send an admission, let me write this better, admission request message. And all that is saying, hey, I want to be able to call 1002. Is that okay? Gatekeeper number one says, do I know where not 1002. Oh yeah, 1002. I didn't use the same extension, but it worked out. So he goes, do I know where 1002 is at? Is there enough bandwidth available to call 1002? And if all those are true, then he is going to send back an admission confirm. Saying, well, absolutely, you can call 1002. As a matter of fact, here's the IP address you need to go to reach 1002. Now, if something would have gone wrong, let's say there wasn't the bandwidth available, it would send back an admission reject, ARJ message saying, no, sorry, you cannot call that number for whatever reason. So this guy then sends, now we're back up to here. He sends that 225 non-RAS connect message saying, hey, I'd like to talk with you. Now this guy, because he's associated with the gatekeeper, is like, whoa, hang on, whoa, let me check. Question, I'm getting a call from 1001 over there. Can I take this? This guy comes back and he's like, oh, absolutely. Matter of fact, I was the one who told him he could come to you. You are confirmed. Now, what's up with that? What that is a double check that the other gateway has, again, not only to make sure that the gatekeeper knows about the endpoint, but also that there is enough bandwidth available to handle that call from both gateways' perspectives, right? So then this guy comes back, and now, shoop, we're back up to this world, right? Without manually configuring all the dial peers back and forth, these two voice gateways know about each other, and they do this full exchange, 225 setup and all that kind of stuff, and life goes on. But now, this guy has a little tracking system. That's my little clock. He's like, hey, I see an active call going between those sites, so I'm going to make sure that I subtract that bandwidth available until we get a disconnect confirm, or a disconnect request. Saying, okay, we're done with our call. Disconnect, confirm goes back, and that bandwidth goes back in the pool. So that's the basics of how the gatekeeper gets involved. Now you can even take that to a whole nother level. You can get multiple gatekeepers as the system scales bigger and bigger and bigger and bigger, to where maybe he's got some of the registrations, he's got some of the registrations, and so you can get to a point where this guy sends an admission request for some gateway way over here, and the gatekeeper's like, whoa, I don't manage that, but I do have a link to another gatekeeper, and he'll send what's called a location request, saying, hey, do you have extension I meant this to be a gateway. Extension 3009, and the gatekeeper goes, oh yeah, absolutely, location confirm. I mean, there's a lot of messages that can go into the gatekeeper once you introduce multiple ones and all that, and they have their own little communication scheme, but all that's governed under H.225 RAS. The beauty, I mean, if you lay it all out like this, it's pretty simple. It makes sense. They're just trying to find the endpoints. They're trying to point you to the right places. But once they have found the endpoint, they always communicate back to the gateway saying, okay, here's your two endpoints. The audio, the RTP, always goes directly between the gateways. And that's good, because these guys never become a bottleneck for your audio. They remain, oh, that's not I keep doing that. They remain what H.323 is designed to do, which is just call setup and call teardown and making sure that the bandwidth is not overrun. Okay, the last thing I want to do is dive into a little H.323 configuration, or I should emphasize configuration specific to H.323 based devices. Now, you know that every dial peer by default uses H.323 unless you specify SIP or some other protocol for it to use. So this is a very common configuration. Now, these general commands at the beginning, I'll say the first one's okay. The second one is huge thing worth mentioning. First one is session transport UDP. This is done from the global service parameter. So let me show you where I'm talking about. Voice service VoIP. Remember, before I said this is kind of like your global settings for all kinds of protocols. So we could go under H.323. And that's where we do the session transport, and you see the command right there, UDP. Now, you can do that on both sides, and it automatically increases your efficiency. With our networks as reliable as they are today, we don't need to do a SYN-ACK, three-way handshake, build a session, tear down the session every single time we want to have a call go between routers. So that gets you more efficiency right there. Now, the second command on there is a big one, because by default, H.323 does use TCP, and most people use it in TCP, because if you do this only on one side, then it's not going to work right. You're going to get failures to call because one side is using the wrong protocol. So let's say, let me just give you an example. Let's say I've got a router right here that connects to site A over a WAN and has a backup through the PSTN. Right? So similar to the redundant configuration, redundant dial peers I was talking before, maybe you have one ... going this way, and that's your priority 0 route because you want that to be preferred, and then one ... goes this way as your priority 1 route, with the correct digit transformations to make sure it gets there. Now you can see right here, by default, H.323 uses a TCP timeout of 15 seconds by default. So let's say the WAN link goes down. Here's what that means. Someone dials a phone over here, 1003. H.323 is going to try and send a TCP SYN message and wait 15 seconds for that to time out before saying, well, I bet that WAN is not available. Do you see my ouch? So you have this redundant peer here, which you'll probably never use, because what person in their right mind sits on the phone for 15 seconds when they dial a number waiting for it to connect? I mean, 3, 5, 10 seconds in, they're going to be like, this just isn't working, and hang up the call. So what you want to do, and this I put this is in voice class mode. So let me show you how to configure a voice class. Voice class is a kind of a modular approach. Let me back up here. You can do a voice class, and then we'll do H.323. It's just kind of a place where you can configure settings that you can then apply to your dial peer. So let's just say 100. We'll make up a tag. So underneath here is where you can set all of your different timers, and you can, let me show you this one first. I'll do H.225 timeout. and hit the question mark, and you can see TCP establish, and then we can put our timeout and values in seconds. Now, I would suggest, as long as you have a decent network, I mean, throw 1 or 2 seconds on that bad boy, maybe 2. I mean, how many networks do you wait 2 seconds for a TCP session to establish? And I would say it's a very slow cross the world kind of network, if so, and then go ahead and make it a little bit more. But the default is just overboard there. So TCP established, adjusting that down to 2 will take this timer. If that WAN link is down to 2 seconds, which most people will be content to wait that long before it fails over. It'll just be like, is that working? Okay, there it goes. Before it fails over to the PSTN. Now, if you switch over to UDP, you don't even have to worry about that anymore, and that's where the other timers come in. You saw the timeout, and you can have the connect timeout. So you can say, I want to wait, such and such number for a connect message to happen. That's after the call is actually established. Or a setup message, when the setup message is going through. That's the first one that is sent. So you might want to reduce, if you flip over to UDP, you might reduce that one down to 2 seconds. Otherwise, you're going to have similar challenges with that call being established. So those are just some kind of big picture commands from there. Now, let's move into the gatekeeper. The first thing worth mentioning on the gatekeeper is that it is expensive. Cisco has a specifically licensed iOS version that does the gatekeeper. And you're not going to get it with your enterprise or advanced enterprise feature set that's on the typical iOS. So when you're thinking about gatekeeper, first off, just go cha-ching. There's going to be a lot of money involved. And unfortunately, I'm not able to get the iOS version that does the gatekeeper. So we'll just talk about the commands. But normally, you would go into global configuration mode and type in gatekeeper. And it would take you into sub-configuration mode, and you can, this is version Advanced Enterprise 12.4. I mean, Advanced Enterprise is supposed to hold everything, but the gatekeeper is such a pricey feature, Cisco broke it off into its own iOS train. So, with that being said, the way that you set up a gatekeeper is you go into global config mode and type in gatekeeper. Now, this device can be anywhere. Let me move my drawing to the right level here. There we go. This device can be anywhere. It could, it shows kind of dangling off the WAN, but it could be in the same office, sitting up here as this guy. It could be even the same router. You can multi-purpose these routers where it's using the same one. It could be anywhere in your enterprise. That's why I have this dangling gatekeeper coming off here. So you go here, and remember, this is going to be the central point that everybody reports to. They get their phone numbers from. They get their bandwidth control from. So this is a key device, and that's why redundancy is always suggested. Use HSRP or VRRP to make them redundant and have a backup gatekeeper at all times. Because if the gatekeepers go down, essentially your whole voice network goes with it. Now, we've got the zone local. Zone local defines the name of a zone that this gatekeeper is responsible for. This is just a logical name. So, for example, I could create the zone local Jeremy and have my own zone. And all these gateways would start registering under the Jeremy zone. And what the zone local means is that this is something the gatekeeper is responsible for. So think of, imagine all these different gateways out here, voice gateways, hundreds of them, that all are attached to the same WAN. And they say, hey, I'm going to register and report to the Jeremy zone. And you can see down here, this is the gateway config. This is where you would go into the gateway and say, I'm going to register with the zone. In this case, I have GK1 being an example, but that's your zone name. So that would be where you would put Jeremy or whatever zone you want to register. So this gatekeeper knows, okay, you're all coming in under the Jeremy zone. You're all my responsibility. So whatever numbers, these gateways will all start registering their POTS dial pairs. They'll say, okay, extension 1001, 1002, all these numbers that are showing up under here will all be part of the Jeremy zone, which this gatekeeper is a member of. So you put, we'll put Jeremy, and then you would put .cbtnuggets.com or whatever domain name you would want as part of that zone. And that's just, you might say, well, why do they have a domain name? Because H323 standards say to. I mean, there's if you went with a non-standard config, you could say, well, I want just Jeremy zone and have no domain after it, but then you wouldn't be following the standard. So Cisco makes you type in a domain name. Now you can also type in on the gatekeeper remote zones, and what IP addresses are responsible for those. So actually, I didn't tell you what this was. This will be your IP address, or maybe you have a loopback interface of 1.1.1.1 that everybody knows how to reach, and that'll say, okay, this is what everybody's going to be reporting to when they come and register with me. But let's say you've got multiple gatekeepers, like I was showing you on the call flow side. So your organization spans hundreds of voice gateways, and all these voice gatekeepers are out there. You can configure remote zones as well, and you might say, well, what really associates something with a zone? A phone number. Oh, right there. So a phone number is associated with a zone. So for example, let me put some of these pieces together. I could go in and do zone. Let's say I type in zone local jar, right? And then .cbtnuggets.com, and this is the IP address. Then I would go in and say the zone prefix associated with jar is going to be, let's just say 1 dot 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 dot. So that'll be any 5-digit number beginning with the number 1. So those are all associated with, and you can see I type in the prefix and I say let me talk about the gateway priority and all that in just a moment. But for now, I'm associating the prefix with that zone, right? I can then start doing zone remote. And let's say I choose Chris as a remote zone. And I say the IP address of Chris is going to be this gatekeeper, 2.2.2.2, right? So what's in the zone remote Chris? So I would do zone prefix Chris 2 dot 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 dot. Is that 4, 5, right there? Which would be any 5-digit number that began with the number 2. So what happens now is as phone calls start coming in, this guy dials 2, 1, 2, 3, 4, goes to this gateway. He's like, I don't know. Let me check with the gatekeeper. Gatekeeper says, okay, that's not in my local zone because my local zone is only numbers beginning with 1 and are 5 digits long. But I do have something in a remote zone, so let me send a message over there to them. Now, any of you remember what that message is? LRQ. Right? It came from that call flow when I said it gets bigger and bigger. So it says, hey, location request, somebody dialed 21234. Do you have that? And he comes back and says, oh, yeah, location confirm. I've got that guy. Send him over to me. So, this guy gets sent over to that gatekeeper, and that's how that works. So really, I mean, these gatekeepers sound really big and complex and scary, but they're really not at all big and complex and scary because you're just going through and creating zones and then associating what phone numbers belong with what zones. And then the gateways all come underneath. You can see we've got gateway. Actually, this is one I can show you. Let me bring it up here on this router. I'll go under interface. Let's say it was using fast Ethernet 0/0 to talk to the gatekeeper. I would type in H323 gateway VoIP interface, which says, well, if I had an IP address on there, this interface is going to be used to talk to the gatekeeper. And then I would say, okay, well, I want to bind the source address, and this is if you want to, the source address to be, 1.1.1.1. Maybe that's a loopback IP address or something like that you're using as the source address for all your communication. And you'd use a loopback, so if any one interface on your router goes down, you could still get to it if you had some redundancy in there. And we're going to get errors because I don't actually have an IP address on this interface. But then I would go in and do H323 gateway VoIP ID, and that's where we would type in the zone name, jeremy.cbtnuggets.com, which would be my zone. And I would say, okay, the IP address that I'm going to use to register with the gatekeeper is, let's say the gatekeeper's IP is 10.5.9.22. Okay, so this would be the IP address of the gatekeeper. So what would happen is this gateway would come in and say, hey, I'm going to register with you, gatekeeper 1. That's going to be the zone that I'm registering in. And you are my priority 1 gatekeeper. You can actually have redundant gatekeepers and different priorities on there. Is this making sense? So let me make sure, again, it's hard without having a gatekeeper iOS to put it all together. So 1, you would, on the gatekeeper, set up the zone, set up all your zone prefixes, what phone numbers are there. 2, on the gateway, I would then use these commands to say, go register with the gatekeeper in that zone. Now, these are active registrations, so the gatekeeper will know, I see you, voice router 1. I see that you have these extensions available. And so this guy would then report to the gatekeeper what POTS dial peers or what extensions it had available on itself. Now, we can even go in there and say, well, this is the ID that I'm going to register with. I can say the VoIP H323 ID is going to be such and such. So I'll say I am router 1. So now on the gatekeeper, I can even go in and associate certain prefixes with router 1, or say whether router 1 is even allowed to register or not. Because this is now a unique identifier that says this is who I am. Now the last thing I want to mention here is this one. And by the way, this is how you add in technology prefix. These default technology prefixes, this is probably one of the most, I don't want to say confusing, but can be one of the most confusing pieces of H323 gatekeepers, and it doesn't have to be. Let me just clear off all that gibberish. What the default technology prefix is, and a technology prefix, is like a default gateway for a gatekeeper. So let's say you've got a voice gateway that's got all kinds of connectivities. You've got a couple PSTN connections on there, different carriers. He's got connectivity to, all kinds of ways. It's like your central gateway to your system. What you could do is say, I want to go and register with that gatekeeper with a technology prefix that is set to its default technology prefix. Now, the reason this gets so confusing is because you might go on Google, after this is done, and type in, default technology prefix and see a lot of examples. The H323 gateway standard says, a lot of these should look like 1 pound star as a, for instance, default technology prefix for the voice system. And you can have, different technology prefixes for fax systems and for, it gets crazy when you start looking at the standard, realizing that H323 is kind of meant to be the standard to rule them all from back in the ISDN days. So they've got all this kind of stuff. But you will see most often 1 pound star being the default technology prefix that you use. So here's what that means. I would go on the gatekeeper. Again, I'm under that gatekeeper configuration mode, and type in the command gateway type prefix 1 pound star default technology. This full command right there. What that does is tell the gatekeeper, hey, if a gateway comes and registers and says, I'm your 1 pound star, then use him as your default gateway, as if somebody asks you how to reach something and you don't know how to get there, instead of just saying, I'm sorry, you're done, fast busy signal, why don't you send him over to that voice gateway, because I betcha he has a route. So on the voice gateway, when I'm up here, that's where I would come in and say H323 gateway technology prefix 1 pound star. If I could put a star in there, right? So here's the flow of how it happens. This guy, once you type in these commands, goes and registers with the gatekeeper. He's like, here, I'm reporting for duty, sir. And during that registration, he says, by the way, I was told to tell you I'm your 1 pound star. Gatekeeper looks at its config and is like, oh, 1 pound star, that's my default technology prefix. You are very valuable to me. And now if any gateway comes into me and says, hey, I'm trying to reach 59, 22, 63, and I don't have a destination for that, I'm going to send them to you. Now, you, voice gateway, and this is, by the way, a little monologue these two are having, right? You, voice gateway, may not know how to get there, but I'm still going to send them to you because you are my default technology prefix. So just think of this as a really big, confusing way of saying, you know what? Gatekeepers need default gateways too. We all need a little default gateway, and this is just the funky way that H323 decided to implement it. I really hope that demystifies and simplifies this H323 gatekeeper concept for you, because I'll tell you, when I first got into voice over IP, I know that sounds crazy, but for years, I was like, I don't get the gatekeeper thing. It wasn't so much that it was hard. It was just one of those, you don't know what you don't know. And every time I would open a book and look at it, it'd throw out things like, like that default technology prefix and be like, oh, there's multiple ones you can have. And I was like, I just don't get it. But once I finally implemented it, I was like, oh, well, There's actually not much to the gatekeeper at all. Matter of fact, the fact that Cisco charges you tens of thousands of dollars for that iOS should make you feel really ripped off when you. I shouldn't say that. Hang on, rewind, edit. That didn't happen. The fact that you spent $10,000 on that very reliable iOS version that is going to support your voice network for years to come should make you feel good when you think about how simple this H323 gatekeeper configuration is. How is that for a good recovery, right? So really the gatekeeper, it's just a router that has kind of a static configuration that says these are where the different prefixes go and all the gateways come and register, and it routes the calls correctly. It's very, very straightforward. So what did we see, and what do I want you to do with this? We saw the architecture of H323, the protocols that make it work, and really broke it down to those three core protocols: H225, H225 RAS, and then H245. I can already tell you what do I want you to do with it. I want you to know those. Know what those protocols are responsible for. They're responsible for doing that call setup. Know that call flow. Another thing that we talked about, the call flow, how the call flow looks and is set up when a call is established with and without a gatekeeper. If you're in the real world, that's very common troubleshooting. You're doing a debug and you're seeing these messages fly across. If you don't know the flow and how it looks, it's going to be very confusing. Also, if you're a certification focused person, then you might get a flow chart on there where you have to drag and drop, when and where those different things happen, and put all the events in order. And then we saw the H323 and gatekeeper configuration, which again, I showed you an example kind of just based off of the syntax, going line by line using syntax. But what I would encourage you to do is go on Google and type in gatekeeper configuration example. And then just take the knowledge that I just gave you by looking at that syntax, giving you some simple examples. And you'll be able to look at it and go, oh, okay, I see, because they'll of course have 50-line configurations on there and stuff I just can't write out. And you'll be like, I see how that works and how those pieces fit in place. So that would be what I would say your homework would be. I hope this has been informative for you, and I'd like to thank you for viewing.